Okay, so we just got finished measuring one side of this cube, and I think the goal of this little exercise is to get the volume of the cube. Okay, so to get the volume, we need to measure off each side. So we've got one side. Okay, we're gonna turn our cube and see how well it's made, and looks to me like it's the same measurement. Okay, so we'll write that down. And then, so we did this way. Now we need to measure the height. Okay. This looks like it might be a little bit different. Yeah, so this is actually a little bit shorter on this side. Okay. So I think that's about 3.10. I'm thinking 3.11 maybe. Okay, so I'm just going to write that down as well. Okay, so there's our values. You know, we can say height, or sorry, we can say width, length, and height. So now we want to get a volume out of this, right? And so we have to think a little bit here about what these values mean and what's up with their uncertainties. So essentially, what we're saying is if we look at, say, our first measurement here, 3.15 plus or minus 0.05, what that really means is this could be anywhere between 3.20 and 3.10, okay? So there's a range of values within which our value falls, okay? So we'll do that for each of them. So then that was width, length, okay, kind of the same thing for length. So we got the same values. So on the high side, 3.20, on the low side, 3.10, somewhere in that range. And for height, okay, this one's slightly different, 3.16. And 3.06. Okay, so there's the possible ranges of values. Now, we have to account when we do the volume for the fact that it's possible that all of our measurements are actually the high measurement. Or we have to account for the fact that all our measurements are actually the low measurement. So you can see there's probably two ways you could kind of go about doing this. And we'll look at them. Okay, so we'll get out a calculator here, turn it on, and the first thing we'll do is we'll find our volume as if all of ours are the high value. Okay, as if they're all the high value. So 3.2 times 3.2 times 3.16. We get some interesting data here, right? So you get 32.3584 on the high side, and that's cubic centimeters. And on the low side, (29.4066 centimeters cubed). I want you to look at these values and tell me what's wrong with them, first of all. Why can I not leave these values like this? Okay, well, what we're saying here, right, up here we're saying, okay, so tenths of centimeters and hundredths of centimeters, right? Here we're saying tenths of centimeters, hundredths of centimeters, thousandths of centimeters, and 10,000ths of centimeters. Well, the smallest value that I can actually read on my ruler was a tenth of a centimeter. I estimated to a hundredth of a centimeter, Okay, I estimated to 100th of a centimeter. But there is no way I could possibly know what this value or this value actually legitimately are because I did not have enough precision going in. So there's a rule about significant digits. I don't know if you've studied this before or not, but basically it helps you to deal with where do I round off to make sure I'm not indicating that I know a higher amount of precision than I could have possibly measured, right? By leaving it like this, I'm kind of lying to you. I'm saying I know this way more precisely than it's even humanly possible with the tools that I have to find this out. If I had better tools and I had more digits to work with, yeah, sure, I might be able to get a value this fine, right? But because I'm stuck with just the ruler, and this is kind of, this is an estimated value anyway, what are we going to do? So what we do is we count, and we say there's 3 significant digits there, there's 3 significant digits there, and there's 3 there. When we're multiplying, our answer can only have a number of significant digits equal to the one with the lowest amount that went in originally. So if one of these only had 2 significant digits, then we'd have to round to 2 significant digits here, right? But since they all have 3, then we can round to 3 on each of these values, okay? So let's just have a look there. There's the third there. There's the third there. So I'm going to look at this number. That's a 5 with a number after it. Okay, it rounds up. So 32.4 for that one on the high side. And this one has a 0 after it, so it just stays as 29.4. Okay, so here's the range within which our value lies. So the question is there an easier way to deal with this and to include uncertainty? And yes, there is. Okay, there is an easier way and I would say a better way. So before we move on to that, let's just see what we would do with this number. So what I would do with this now, if I have a range like that, is I would find the center of that range, so 32.4 plus 29.4, and this is just by doing a simple average divided by 2, gives me 30.9.